Okay, any question compared to for the previous lecture? No question, huh? Okay, let's see how we apply what you learned just now. Huh? Again, just recap what are the important equation. As what you see here, you can convert the normal motion equation into angular motion by changing v into alpha, v into radian or theta, acceleration s into theta, v into omega, a acceleration into alpha. Then an and at, an equal to omega square r, at equal to alpha r. So these are the two important equation. And to link the v equal to omega r. Okay. So we're having this system, two motor round body with a belt. The motor on the top is rotating at the acceleration of 2 radian per second square. Radius is given 0.15 meter. It was rotating, transmitting to the lower belt, lower wheel there, with a radius of 0.4 meter. Interest point is P. If the pulley A connected to motor begin to rotate from rest, angle 0, omega 0, acceleration 0, with a constant angular acceleration 2 radian over second square. Determine the magnitude of velocity and acceleration of point P. This one need to be careful. The question asks you about velocity and not angular velocity. If the question in front of the velocity don't have angular, it means v. If you see angular velocity, means omega. If the question stop here, like what you see on the example 2, you are finding v, not omega. Acceleration also same. This one asks you to find an and at, basically. An and at on the wheel after the pulley have turned 2 revolutions. So 2 revolution means you're given the angle. 1 revolution is 360 or 2 pi. 2 revolution is 4 pi. Assume transmission belt does not slip on the pulley and wheel. Does not slip means no change, no 100% transmission. 100% transmission. So angular motion, you convert the question into radian format. So you have 4 radian. Theta that happen is 4 radian. Not 4 radian. 2 revolution, 2 pi radian. 2 pi radian. Put in at least 3 decimal place or 3 significant figures. This case, you can put in 12.57 radian, or put in the simpler form 4 pi radian. So, since it was having a constant acceleration, it gives you constant angular acceleration, means A constant, not A constant, alpha constant. So alpha constant, you can use the equation you derived just now. We want to find the angular velocity, which is the omega. Yeah. For chapter 5, no matter how the question asks you, you need to find the omega. You need to know what is the omega at the end. So find omega first. Okay. So equation, you can choose anything that any 3 of these equation to find the omega. So we choose the omega square equal to omega O square plus 2 alpha and the change of angle. You substitute the value. Omega O 0, start from rest. Alpha is 2 radian, given in the question, 2 radian. Theta is 4 pi radian minus 0, or 12.57 radian minus this one. This one should be 0. So it should be 0. Yeah. So you square the value again, square root, you have plus minus. You have plus minus, you are dealing with vector. This one, you follow the motion, you use the positive value. You follow the value, follow the motion, you get positive direction. Once you get omega, the rest is just substitution. Once you get omega, when you have omega, you can transform this. You can start to use this equation already. V equal to omega A, RA. And this omega cannot transform from one object to another object. So when you found this omega for A is not same as omega for B. So it has its own set. But the velocity do not change. Velocity that you transfer do not change. Okay. So you write V equal to omega R for object A equal to omega R for object B, because the belt transfer the same speed. From this equation, one is missing, which is omega object B. Just now you try to find object A, because object A, you have a lot of information that allow you to find omega for that object. So once you find omega for one object, you need to find, if for this example 2, you need to find omega for B. Then what link of object A and object B is a velocity. Velocity is the same, transmitted from A, transmit to B. So from here, just be careful on the unit. You are dealing with radian, not theta. Rearrange, you get your omega B in radian per second, 2.659. 2.659, or you can write 2.66, the minimum. Don't write 0.7, 2.7. 2.7, wrong answer for test 2 and final exam. It's not accurate enough. So you need to give at least 3 decimal place or 3 significant figure. Once you get omega B, it asks you to solve what? Determine magnetic velocity of point P. Point P fall on where? Fall on object B. So you forget about A already. You forget A, go and solve B. So B, what is important is the omega B. You need to find acceleration. Recall what is the acceleration of equation. AT equal to alpha R. So AT equal to alpha R for object A, same with alpha R for object B. The velocity and acceleration is transmittable between two bodies. You're using belt. So the only common entity that you can transfer is a velocity and acceleration. Okay. You put in, you are focusing on B. So you write AT equal to alpha B RB. So here you link with these two, alpha R for A equal to alpha R for B. You know the angular acceleration for A, so substitute 2 radian per second square. You have the radius for A. You don't know the alpha B, you know the RB, so you can find alpha B. Once you find alpha B, what else? Okay, then you start solving vector already. Once you have that one, you look at P in a circular motion. So P have tangent and normal direction. So AN and AT. So you start converting. VT, V equal to omega R. You have an omega already. But remember, this one is object B, not object A. So don't confuse the omega. Omega cannot transfer one. Omega stick with dead bodies. Cannot transfer. What can transfer? Especially when you use belt, what can transfer? Velocity and acceleration. So you substitute this one. You have omega already, you have R, you get the velocity for point P. Again, point P in the circular motion, Vp is tangent velocity. Okay, so this one, you multiply radian per second with meter, you can convert into meter. Don't ask me why radian divided by meter equal to meter per second. There's a conversion. There's a conversion. But you press calculator is a unit in meter per second. Okay. This radian can change to meter because of this S equal to R theta. This concept. But anyway, when you do your calculation, you don't need to write unit anyway. You don't need to write. But if you want to write, go ahead. Important is your final answer. Please, your final answer, you need to click write units. So Vp AT equal to alpha R. Still substitute. Careless mistakes is that you will use the wrong alpha or wrong omega. Just focus. So this one fall on the object B. So you alpha A acceleration equal to angular acceleration multiplied by the radius alpha B. Substitute, you get 0.3. What about normal? Normal is omega square R. An equal to omega square R. You have the omega for B, but this one square multiplied by the R of wheel B is 0.4. You get the An for B. Okay. The sequence of solving question always same. You look at the motion, look at the axis of rotation, where does it rotate? Then if you have the belt, normally A can transfer, V can transfer. Find the omega first, no matter how, go and find. And try to check. Usually the question will be constant acceleration. Constant angular acceleration. Okay. If you want to find the resultant, the question asks you about acceleration. Acceleration, this one actually is a resultant. So square this one, square root. Get the answer. From your free body diagram, actually you can draw the tangent, the angle between tangent from the horizontal or from the center or from here. You can draw your theta here. Theta equal to tangent, inverse tangent of normal and tangent, if you want to find angle. Right? But, two slide, this one. Angular, this one. Earlier. This one is what I wrote on whiteboard here. You're using this one. The rest is substitution. Okay. Okay. Recall just now, in motion, we have three types: translation, rotation, and general plane. Now we look at general plane. Okay. Just now we look at rotation. All the calculation angular is rotation. the V and A, they are translation. V and A, they are translation, rectilinear, collinear motion. The rotation is the angular motion, the angular velocity, angular acceleration, that is rotation. Now we combine two. We see how we solve, huh? So this is like in machine design and all this, all right? You need to recall cosine rules in next chapter. What I mean by cosine rules? Chapter 5, cosine rule is important, or cosine law, where you don't have a right-angled triangular. A, B, C, C, B, A, and there are a few lah. This is one of it, one of it. To find the side and the angle. This one, go home, go and find what is cosine rules. This is just a illustration, okay? Okay. Now you look at example 3. Example 3, you have a round bodies rest on O, and this one have a spring, and this object is rotating clockwise. It give you alpha and omega, give you the R, give you the X, C point, B point, and you have the R. End of the rod remain contact with the cam by means of spring. If the cam rotate about the axis passing through point O, this one, rotate, with angular acceleration alpha and omega, determine the velocity and acceleration of the rod when the cam is in the arbitrary position theta. This one is just ask you to change from V into angular things. So coordinate this one, theta and x, theta, this one, theta and x are in rotation motion. The cam, this one is in translation, in one straight motion. So we start to derive some of the formula. You are having a right angle triangular there. OC equal to R cos sine, this C, OC. So your X equal to 2 of this OC. Okay, OC or CB, they are cos, R cos theta. So your X equal to double the side of the triangular. So X equal to 2R cos theta. Why you need to find this one? Because you are finding velocity in a straight line. You need to convert the rotation into X direction. And in this case, you see positive direction pointing to the left. There's a meaning for this arrow, mean X positive to the left. This is a hidden message, actually. So once you find that, you need to find time differentiate of this equation. You're using chain rules. Equation appendix is given, so go and find. So you do V equal to dx dt. You want to find velocity. Velocity equal to displacement and time differential, dx dt. So this is two unknown. One is U, one is V. You do chain rules. You arrive at this one. So you rearrange. D theta dt is omega. Then you put omega inside here. Okay. How to from here to here is using chain rules. There is a website on the on the Google. You go and find. Um, what is how you find the calculator for or differentiation calculator. You put differentiation calculator, then then will come out like the first two. Then you click inside there. You put in dx you put in dx dt. What is your x? You put in d something and d something. You press calculate. You can even click the find show steps. It will show you how to do the chain rules. Okay. But anyway, we continue with our discussion. You do chain rules v equal to this value. Acceleration, you do need to do another chain rules again, but differentiation steps is a bit lengthy. It's a differentiation steps of this one, u and v chain rules. At the end, you arrive at this one. Oh, too fast. Okay, you arrive at this equation. Minus 2r bracket alpha sine omega square sine theta. Okay, so your homework today, go and find what is cosine rules. Revision on chain rules. How to do differentiation, chain rules. D, U, V, how to do this one. Okay, DUV, dx or dt, how to do. So go and find how to do chain rules. Once you have your A, V, and T, this is a cosine rules that I write on the whiteboard just now. So if you can't remember, you draw a triangular, label ABC. The opposite angle of that side is the C. Opposite is the same, BB. Opposite is A and A. Inside is the angle. Then you remember C square equal to A square plus B square minus AB cos C. Then you compare, so this one, sorry, this one is another example already. Sorry, I jumped too fast. Example 3, just to test you on the derivation. Actually, the purpose of example 3 is to recap chain rules. Okay. Example 4 is a window design. So window design, you open this piston, you open the window, this arm O, this arm will open up, and this piston will change. This angle will change. S will change. The pin from here O to B is 1. B to the length is 1. Total length is 1. Total length of the window is 2. It asks you to find what? A window open using hydraulic cylinder AB. So AB. If the cylinder extends at a constant rate 0.5 meter, means this one, you push this arm at a constant rate 0.5 meter per second. So this one will rotate at a constant rate also. If this one push, constant rate, translation, it will make this one rotate that way. So look at your right hand. Rotate that way. So the axis is pointing up from the screen. Okay, you rotate that way. Determine the angular velocity and angular acceleration of the window at the instant theta 30 degree. So before you start, don't substitute 30 first, derive the equation. So before you derive, you need to apply cosine rules. Why? This is a triangular that is right angled. You don't have the right angle here, but you can convert this triangular using cosine rules. So in this case, you can put your C as alpha. Your C, this one, C as your alpha. Your B is your 2 meter. A is depend on the pin. So this one is O to B is your A, small a. Your S is your C. Then you write C squared equal to A squared plus B squared minus 2AB cos C. Then you modify accordingly to the question. So here, your S is your C here. This one equal to this one. So S square equal to A. A is OB, this one. OB square plus, so AO, AO or OB minus A and B cos theta. Okay. So you arrive at this equation. OA square, OA is 2. 2 square is 4. OB is 1. 1 square is 1. So 4 plus 1 is 5. This one, 2, 1 is 4 cos theta. You get the first equation. Ignore the A. A is typo error. So you just substitute 30 there. 30, you know your S. But remember, it's a square. Square, so you need square root. Typo error in my answer, no A there. So your time derivative means you continue to find S square equal to something. You need to find the acceleration. Not acceleration, your velocity first. Velocity first. So this one is ds square dt. Okay, ds square dt. So this one is you break into ds dt, ds dt. Okay. This one actually is a chain rules lah. It's a chain rules. So you just split this one into this one. Here to here is there's a chain rule there. There's a chain rule there. So this one 5 constant 0. This one you pull the 4 time differential cos, you get negative sign, and then you integrate this one more time. So ds dt is v. Ds dt is v. D theta dt is omega. So you have two equations. So velocity v is 0.5. Means vs, velocity of this piston here is 0.5. Angle, you know, 30 degree. S, you know, S is S is okay. How to find this one? I give you a notes here. How do you solve this one? Become this one. There is a side note here. dt d square v square is equal to 2v dv dt. Okay, this is a chain rules. So equal to 2va. So you arrive at this from here to here. The side note is this one. Just now you find your S, right? You find your S already. Substitute inside equation 2. So just now from the previous slide, as you substitute, V is the given from the question, 0.5. Theta, you know, so only have one unknown. All right, 1 omega. Omega, you need to give direction. This one is anti-clockwise. It's anti-clockwise because you push the window out. It's anti-clockwise. So you can put either in a minimum 3 decimal place. Minimum 3 decimal place. If you remain at 0.6197, also correct. Not less than 3 decimal place. So you take time differential again. The purpose is to find alpha. So we have two equations. Then you take time differential again. Time differential again. So you time differentiate this one, the whole thing. I'll let you know if this kind of question come up, so you can prepare. Most of the time, I won't ask you question that related to chain rules. I won't ask you. Right? Okay, so this one, the left-hand side, this one is actually is a chain rule time differentiate of this one. This one is the time differentiate of this one. This one is U, this one is V. Time differentiate chain rules, these two, you get this one. At the end, you substitute, you get alpha. So when you get negative, it means the angular is a deceleration, means the angular acceleration slow down when it reaches 30 degrees. Okay. Again, I rarely ask example 4 kind of question. I rarely ask. If this one come out, I will let you know. Okay, the rest is just repeating what we learned, relative motion. If you look at this diagram, one is fixed reference, one is another moving motion, moving axis. From fixed to point A, from fixed to point B, so you have RA, RB, and in this case, you are looking at from A to B. You're looking at A to B. Just now, the example that you see is from B to A. Just now, the example, you will see the B at the top, A at the below. This one, the arrow pointing here. Arrow pointing here asks you to find RB stroke A. Again, if you can't remember which one and which one, just change the slash into negative. You write RB stroke A equal to RB minus A. You solve this one. So this one, if you look at this triangular, starting point is here, end point is here. So basically RB equal to RA plus this one. This is start, this is end. Because you look at the arrow, this is start to end. This is the process from this O to A, then from A to B to reach B. But again, if you can't remember, just change the slash into negative. Okay, the rest you read. I want to highlight the important part. So this one, this equation, you should able to read from the vector diagram. Again, if you don't understand the vector, you can just convert the slash into negative, then write RB slash means negative RB, RA in this case. Okay, displacement, always you know already. So if the object move from this one to this one, so this is a general plane. Okay, you can see the orientation change a little bit, right? So why general plane? It consists of two actions. This is before, this is after. It consists of two motion. One, I put my marker pen here. One is move from B to A, B to B prime, like this. It move from like this translation. Then it rotate at a certain angle. Okay, this one, like this. Then it rotate. Or it rotate first, then translate. Both action, doesn't matter which come first, it arrive at the final answer. So this is just a explanation what actually happened before to after. So here, how to read this one? First, you look at point A, put in axis for point A, X and Y. Then A will move parallel. Okay, you fix this one, you move parallel, you arrive at this location. This is translation. So DRA is a translation. DRA will be the same as here, same translation, but you need to a rotation at point A to form the final shape here. You need to rotate like that. Rotate by what angle? D theta. And when you reach here, when you reach here, there's a vector. There's a vector. So this vector, this arrow, and this arrow point here. How you find this arrow? Copy the previous one. This one point here, you just transferring or translating the whole thing. This whole vector still pointing down, you just transfer in the straight line. When you transfer, you draw the arrow, but you need to rotate. When you rotate, the arrow is pointing from somewhere to somewhere. Somewhere to somewhere, this is B prime. B prime, this one is the changes for B stroke A. This is a rotation. This is a rotation. B from A, or this one you can just put as A lah. You can just put at A. This actually following the A, rotate or vector pointing to B. So this one, dr B stroke A means from this point. It should be, I mean the proper way, it should be B slash B comma. It should be right B slash B comma, but B comma, this one actually is the same as A. So you just look like that lah. Okay. I just want you to show, if you understand the motion, it basically consists of two, this is a general plane, it move in translation, then rotate. You can solve this question by looking at rotate, then translate, also same. Okay. Due to rotation about A, This one, you see a triangular here. This one. So this is a triangular. So triangular, because this is in radian. In radian, you can use S equal to R theta. This small distance equal to R, this RB stroke A multiplied by the angle. This is your S R theta. This is a small S equal to R theta. Like what I draw on the whiteboard here. S equal to R theta because we are looking at radian. This is a small curvature, small circle, small section of circle. When you rotate, this one actually rotate in a circular motion. Okay. Displacement of B, this one, displacement of B, here to here, here to here, there's another triangular. Triangular is this one equal to this one plus this one. DRB equal to DRA plus DRB stroke A. It's just reading from this triangular vector. Then you put the top one, substitute inside here. Put this one, substitute here. So you have three lah. On the left is translation and rotation. On the left means from here to here is a result that you want to look at. RB equal to DR is this one, is a translation of A point plus rotation. This is due to rotation about it. Okay. Now, why you learn all these things? We look at one tutorial question, then we call it a day. Velocity, you know lah. Once you have displacement, you have velocity, you can do time differentiation. Time differentiation, you get VB equal to VA plus V stroke B. This only happen in general plane analysis. You look at this. Or again, if you forget how to write this one, the question will ask you to find VB stroke A, you don't know. You just write VB stroke A, change the stroke into negative. You write VB stroke A equal to VB minus VA. You still get the correct answer. Acceleration still same. The rest you read. The rest you read is a derivation steps. This is for your info only. That's for your info. General plane equal to translation plus rotation. That's it. The rest is a lot of information there. You just read when you have time. When you have general translation, you draw this diagram. You draw what is the motion, what is the combination of motion, fix one point, and then you draw the diagram. Usually, general plane, you need this one. VB equal to VA plus VB stroke A. You need to draw this diagram, but I will show you by example. This one, just for your info. Just recall what is V. V equal to omega R. If it's in three-dimensional, only you use cross products. Omega cross R. Always omega cross R. Okay, example 5, then we call it a day. All right. You have a link or window link here, A, point B. The distance between A and B is given 0.2. So when you slide down point A, point B will move to the right. Velocity A is given. B, you don't know. Angle is given. So if the velocity of A is given, determine B when it reach angle that one. So you don't, maybe this one is very confusing. You only focus on the two dots on the object. You draw the object, AB, ABC. You want to draw ABC also can. You draw the object, draw point A, point B. Because the question asks you about B, sometimes you can ignore C lah, because the question doesn't give you C. Didn't ask you about C, so you can just, in your free body diagram, you just ignore it. A, you know velocity go down, so you just copy the velocity vector, put in A. Put in 45 degree, question ask you about 45 degrees, so you just copy the angle. B, you know B in the fixed log. So velocity follow this way only. So you draw to the x direction. For rigid body, velocity is important, omega is important. But the most important one is omega. So again, die also you need to find omega. So you need to have a good sense of what is the direction of omega. So when omega means the twisting rate of twisting, angular velocity. So this one, when A move down, you know that this body going to twist anticlockwise. So put in anticlockwise, omega. Okay, you look at that component. So this one A move down, this one rotate anticlockwise. So you draw anticlockwise omega. Tell me where is your positive direction. Y go up, positive, go to the right, positive. Again, the question already fixed to point B, so you focus everything on point B. Okay. And this one, you add in one more vector, A to B. You write an arrow, you draw an arrow, vector R from A to B, you draw. Then you label as, because this arrow is from A to B, so you write R, B, stroke A. Again, stroke B, in front the stroke is your target. Behind the stroke is your target, your source. From where? Slash is from where? From A. So B stroke A. Don't write wrong, huh? Don't write wrong. This one must tally with the arrow. When you have arrow, you can draw triangular cosine rules already. Here you have the distance. You have the distance here. So I just copy. There are two ways. I give you vector analysis first. You convert into IJK. This one, maybe I write too fast here. This one, VB equal to VA plus VB stroke A. You convert VB stroke A into omega cross R because it's vector analysis. You put in IJK term. Typo error here. My I should be big enough. So this one, VB go down, go to the right. Right X direction is I. So you write VBI. VA is go down. Go down is J, but it's go down negative because Y go up positive. So minus 2J. Bracket. Omega. Omega. YK. If you draw three-dimensional, X, Y, your Z, you use your right-hand rules lah. So this one is this one like that. Okay, so you write that. Your thumb is pointing out, so your Z is go up positive. This one is positive. From go out from the screen is positive Z. Go inside is negative Z. So here, we have a positive k, positive omega k cross RB stroke A is this one. This is a vector. You have 45 degree. You can split this one into x direction, y direction. So x direction is RB stroke A cos 45. Y direction is RB sine 45. Sorry, cos 45. Your x is sine 45. Huh? Just now I make wrong already. X direction is sine. Y direction is cos. Then you do multiplication. K cross I. K cross I, what you get? Positive J. K cross I, you get positive J. K cross J. K cross J, negative I. Negative, negative, get positive. Yeah, because negative here. So you do the K cross J, get negative I. But because of negative, 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 get positive. Then you group them by direction. I with I. So VBI equal to this term. J basically is 0. You understand, right? So VB, this one is grouped by I. So I identity equal to I identity. VB equal to this magnitude. This one don't have J 0. Left hand side 0. So J plus J, you get this one. So you can solve this one, you can solve your omega already, second equation. Once you find omega, substitute here, you get your VB. Yeah. Once you find omega, tell the direction. Direction is anti-clockwise. Substitute back here, you get your VB. Oops, sorry. VB, your answer is positive, means it agree with what you predict. You get your answer positive. It means it align with what you draw in your free body diagram. If you get positive, align with what you draw. So positive, go to the right. This one, your homework, go and see scalar analysis. Scalar diagram different already. Go home and see. This is your homework. Change already. Okay, your homework. If you've got question, come and ask me. Example 6, your homework. Go and see. I will upload in Canvas later. Next lecture, we look at 5.6.